we're going to look at the intermediate value theorem, which I write as IVT, and we're going to talk about how it works. Okay, so the idea of the intermediate value theorem is that you have to first be told that your function is continuous. And it has to be continuous on an interval. Okay, so it doesn't have to be continuous everywhere, but I have to be guaranteed that for wherever I'm looking at it, it has to be continuous. Okay. The other thing that we're going to talk about, which is a little bit strange, is that we're going to talk about the endpoints, which are f of a and f of b. Okay, so let's go ahead and just kind of draw a picture. So let's say that I know that it's continuous from, let's say, -1 to 3. Okay, so let's say that's my a and b is -1 and 3. Okay, now let's pretend that for -1 I have a y value of 5. Okay, so this is 5. And let's say that my y value over here is -4. Okay. Now, I know that the function's continuous, so that means from here to here, when I connect those 2 points, it's never going to break. It's never going to be undefined. So I could be lazy and just connect the points with a straight line. I could be kind of crazy and put some bumps in it. Heck, I could even have it dip down and then come back. Okay, so it looks like a weird mouth right there. But basically the idea is that we know that it's continuous, so I can go from here to here. Okay, what the intermediate value theorem says is that, okay, we're not really sure what it does between these 2 points, but I know it has to exist at least between these 2 values. So we're saying that we can guarantee that we will have y defined between -4 and 5, my high and low of this graph. Now, I don't know for certain if it'll go below, like in this picture, or if it'll go slightly above, like in this picture, but I can guarantee this. Okay, now, before I go any further, think of this like your car. If I knew that you were going 0 miles per hour, and then I looked at you driving 2 minutes later and you were going 60 miles per hour, I can guarantee that you went every speed between 0 and 60. However, I can't guarantee that you went 85. You may have, but I can't guarantee it. That's what this is saying. This is saying that I can only guarantee y values between here and here. Okay. So what the intermediate value theorem says is it says, hey, if you pick any y in here, then there has to be an x between -1 and 3 when this happens. Now, how did I get the numbers -1 and 3? Because that's my values, -1 and 3. Okay, so we're saying if we box out in the y direction and box out in the x direction, that this has to be true. Okay, so if I were to pick, for example, the y value of 2, and let's just say for simplicity's sake that that's the y value of 2 right there. Okay, on this picture, we can see that it's happening at an x value of 0 for this line example. If I'm looking at this crazy upper wiggle, it looks like 2's happening right about there. So that looks like maybe for this picture it's happening at x's 1.5, we'll just say. Again, notice that x value is landing between -1 and 3. Okay, for this bottom graph, 2's happening over here. So that's looking like it's happening at -1.5. Okay, so what I'm saying is that all these x values that I'm guessing are x values that are happening between my x bounds. So the most important thing about the intermediate value theorem is this right here. The only way that you can say this is true is because we made the statement at the beginning that the function's continuous. If the function's continuous, then that means that this will follow. Okay, now how we use this in our homework is actually very specific, talking about solutions to equations. So that will be the next video.